So what we're going to do is we're going to talk about the dependency inversion principle, which is, as I mentioned before, the last part of the, let's see here, the last part of the solid architecture principle. So we've been through the single responsibility principle, the open closed principle, the Liskov substitution principle, the interface segregation principle, and then now we're on the dependency inversion principle. Now, I have to be honest, I have what is in some ways a limitation and some ways kind of a cool thing, which is that I really don't have an easy time understanding these principles based upon these kinds of definitions. Now, I'm not saying that these definitions are bad, I'm saying I have trouble understanding them. So instead of talking about this stuff really verbally, which I've seen a lot of people do, and I don't really learn anything from that myself, what I will do is I want to show you sort of the first time, as sort of a personal experience, this will be the first time that I sort of started to see, and this is true, I'm not just making this up, this is one of the first times that I started to see how the way you structure your application can solve enormous problems before they even become problems. And what I mean by that is, well, let's get into the demo. So before we get to the demo, I'll give you the sort of the standard verbal definition or technical definition of the dependency inversion principle, and then I'm basically going to leave that and hope that I basically explain this, but just by example, because so what we're looking at here is so there's two parts to this. High-level modules should not depend on low-level modules. Both should depend on abstractions. So again, this is a little bit difficult because like it's not immediately evident to me what exactly a high-level module is or a low-level module, but the way I think about it is I would say like a high-level module might be something like, let's say we're building just a 3-layer architecture. Let's pick a really simple example: model, view, controller. So in this case, I would think of each of those as high-level modules. And why are they high-level? Because we're not very specific. We're not worried about finer details. The view draws things on the screen and relays stuff to the, sorry, did I say presenter? Sorry. The view draws stuff on the screen, relays stuff to the controller. The controller sort of communicates and makes logical decisions between the other two layers. And then the model is responsible for sort of data, structured data management and access and storage and things of that nature. So that's what I would think of as a high-level module. Versus a low-level module, I would assume would be something like a service class that would fit inside one of these things, but I'm not entirely sure. It's, yeah, I have trouble with stuff like that. But the second part is that they should both depend upon abstractions. Now, in doing research in the dependency inversion principle, one thing I learned is that so this is something I assumed at first, but I assumed an abstraction meant specifically like an interface or an abstract class in Java. That's not, apparently, that's not really what is meant, and that's kind of where we'll get into the interesting example stuff. As for the second part, B, abstractions should not depend on details. Details should depend on abstractions. Again, I think what they're saying there is basically, well, let's get into the demo and I'll try and revisit that, but chances are I'll probably forget. But my hope is that when we go through this example, you will see in code and in the architecture why this stuff helps, because we're going to be solving a problem by changing our software architecture. So let's get into the code. So what I'm going to do is we're going to look at two different sort of sample problems and sort of sample data structures, and we'll see sort of, I hope we'll see where this thing sort of starts to make sense. And first I'm just going to move this over to the other side. Move to right. Perfect. All right. So let's first look at So this is what I would kind of call a bad solution, and we'll understand why it's bad later on. But what I'm going to do is I'm going to open up these three classes and we're going to talk about them a little bit. So our three classes are basically, so I want you to sort of assume we're building like some kind of three-layer application. This thing could be called Note Controller, it could be called Note Presenter, it could basically even be called Note View Model, although it wouldn't actually really talk back directly to a view, which the thing is, this is pseudocode. This is not supposed to be like a really concrete example, but I just want you to keep in mind, you could apply this in any of the three major architectures. It really isn't architecture specific here. So let's just briefly talk about our first class here. So just in a nutshell, we're just going to go with Model View Presenter. That's what I'm comfortable with. And what a presenter does more or less is that it talks to the two different, it'll talk to the view and it'll kind of both handle the input from the view and it'll tell the view what to do. The view is kept pretty dumb. So that's basically its responsibilities. So in our first example here, what we have is we have this thing called Note Presenter. And the big thing that we need to do here, and this is our challenge for today, is we need to save data to both a local and a remote repository or database or whatever. So just in simple English, we want our data to be saved on a device and also in the cloud, which I hate that term because the cloud just means someone else's computer. So it's either going to be on your device or someone else's computer. So that is our problem. And the way that we've chosen to solve it first is we've created this Note Presenter, and of course it's going to need to be talking to some kind of data manager thing. And in my first solution, what I've done is I've said, okay, well, obviously I need a Note database. Now there's no implementation in these examples because it's beside the point. But let's say this could be like a Realm database. It could be a Room database. It's something local. We also have a sort of a remote data store, and that would work through some kind of network service. Again, there's no implementation, but if you want, you could think this could be retrofit, it could be volley, some kind of REST communication API. And so basically what these things do is that we're going to just pretend that this thing only has to do one thing. And basically what happens is at some point, the view, doesn't matter what it is, a fragment activity, I don't care. Some view says to this presenter, hey, the enter button was clicked and here's the user input. So let's imagine it's a note-taking app. The user inputs their note, hits the check mark, and then the view says, here's the input. So in our first solution, what we're doing is we're taking this user input, of course, from the view, and then within our presenter, we are saying directly to these two sort of concrete classes, and by concrete I mean they're not interfaces, more specifically, we're saying to these two things, hey, Note database, save it. Or Note network, oh great, we got the garbage truck outside, my old friend the garbage truck. I feel like Elliot Hulse anyways, but random tangent. So we basically just say, hey, save Note on these two different services. So as a beginner programmer, you might sort of type out code like this, give yourself a pat on the back, crack a Mountain Dew and slam it, and you're done for the day. But it turns out that this is actually a pretty crappy way to solve this problem. And let's talk about why. And this is where things start to get a little bit more technical. So there's two immediate issues that we need to talk about here. And those primarily have to do with responsibilities. So what is our presenter supposed to do? It's supposed to take input from the view, make decisions about that input, call whatever service, the data service it needs, or the repository or whatever, and then sort of, if it needs to, call back to the view. But it should make decisions, and that's basically it. It's kind of like passing stuff around. I kind of think of it like. So that's its sole responsibility. Now, in this first example, we have two primary issues with this. And this is where we start to get into sort of the high-level stuff. So our high-level module, or our high-level class here, which is the note presenter, I want you to take note, excuse the repetition, that it knows very intimate sort of details. It knows specific details about the sort of the data side of the application. So what I mean by that is it depends directly on our two services. So we'll see why that's kind of an issue in a moment, but I just want you to take note of that. This note presenter depends, as in it holds reference to two different services, and these two services do exactly the same thing. Their implementation is different, but conceptually, all that they do is they save a note, which if I'm not mistaken, that is the abstraction we're talking about. Not an abstract class per se, but the abstraction of the presenter, or sorry, the abstraction of the data layer is sort of that its job is save note. And instead not instead, but now we have a case where the presenter A knows that we have two different services and just knows more details than it really needs to. And the last thing I'll harp about in our crappy example is that the note presenter creates these things. So when the note presenter is created, we create our two database services and we assign them. Now this is problematic simply because we have added an extra responsibility to the presenter, which, sorry, I'm like a Nazi about typing, which is the creation of its own dependencies. Dependencies. There we go. And that is a responsibility. Object creation is a separate thing. So we're kind of our presenter, and this is what we'll leave on with this crappy example. Our presenter knows more than it really should, and we'll see what I'm talking about there in a moment, about what's going on in the data module of the application. It knows like intimate details and it knows concrete classes. That's an issue. Secondly, because we didn't use any kind of dependency injection, it now has the extra responsibility of creating its own crap, which breaks the single responsibility principle, which we talked about in the beginning of S.O.L.I.D. So this is kind of a crappy solution, and this is probably something something I would have seen in my old code, basically. And what we're doing is we're saying, okay, we need this presenter. Okay, I know that it needs a local and a remote data source. Let's just plug them into the presenter. The presenter will talk to them, whatever. That's a crappy solution. Let's talk about a better solution, which, if I'm not mistaken, applies the dependency inversion principle. But whatever, let's leave the words aside, and I will just show you how we can just build a better architecture, and hopefully it sort of coincides with the whole big words thing. All right, so in our second example, we've changed a number of things. I really wish I could zoom in on this side panel, but I have not yet figured out if I can. It doesn't appear I can increase the font size over here. But just really briefly, we've divided things into separate packages. In our first example, we just had this note database, note network service, note presenter. Everything's in one package. Everything depends, is tightly coupled, blah, blah, blah. In our second example, we have a package for the presenter. We have a package for the repository. Let's ignore this inject thing. It's just so that I can write inject here, but it's not actually dagger 2. And when I open the presenter, all we have in there is the presenter. And when I open the repository, boom, all of a sudden we have like this little class explosion going on here. So we've got this note object, which is just the POJO. It's not really relevant. It's just basically a string. And what I've chosen to do in this case is I've said, okay, and this is where things get interesting. So, as I mentioned before, at the higher level of things, this presenter is concerned about talking to our data module, and the view. It should not be concerned with how the data module works at finer detail. It should just, at the highest level, it should just know, I want to be able to call something that saves data, and that's all I want to worry about. So, as opposed to depending upon concrete classes, instead what we're doing here is we've created this note repository object here. Now, that should actually be note data source. Sorry about that. That should actually be note data source. I apologize about this, screwing up my own. So instead what we're doing is we are actually depending upon an interface. Let's have a quick look at that interface. So all this interface does, and I want you to think of this as like a very high level sort of abstraction thing, is we're basically creating this contract that says whatever implementation or concrete class that implements this thing must be able to save notes. And this is what our presenter will be depending upon. It's not going to care if it's a local repository, a remote repository. It's not going to need to know or worry about any of that stuff, and it shouldn't. Now, what we're going to do instead is we're going to, so there's two things. Number one, we're now depending upon an interface. So that means that we can basically mix and match whatever we want behind the interface as long as it implements the contract. So we'll see how that benefits us in a moment. But a second thing we've done, and I'm not going to talk a ton about Dagger 2 here, but we've also used a dependency injection framework. So in this case, I've mocked Dagger 2 with an inject annotation. But basically, in a nutshell, let me explain dependency injection in like a minute. So if it's not dependency injection, this presenter creates its own dependencies. That's it. Like the previous example, new data repository, whatever it's called. That's not dependency injection. In this example, some other thing, a framework in this case, Dagger 2, creates the repository and gives it to the presenter. That is dependency injection in like a minute. It's honestly dependency injection itself. It is like, it's a concept that a child could understand. Dagger 2 is not something a child could understand, but we won't get into that. So we've done two things. We've basically fixed our presenter so that it really does only have the one broad responsibility, but it's not worrying about creating its own stuff, and that's the first sort of issue I wanted to talk about. And the second thing is, let's have a look at our data source, because things have changed a little bit. So as you probably notice here, we're just calling one data source. We're saying note data source.save note. Now, as I mentioned before, our primary problem here is to save to both a local and a remote repository. So if you're a beginner or you're not familiar with this stuff, you might be wondering, like, well, what's going on here? Like, there's only one class here. Let's open up the note repository. So this is kind of a facade pattern going on here. I've heard it called the repository pattern. If you want to sort of Google that further, facade, F-A-C-A-D-E. I believe it is a French word. So let's open up the repository. So I want you to notice two things. For starters, we've created this new layer, this new class called the repository. Now, our note presenter doesn't even know about it. Like, yeah, it gets passed in here, but we could pass an interface in, but that doesn't really matter. This thing gets, after the constructor executes, this thing is, what do you call that, not instance variable. I don't know, I forget all those stupid names, but it's going to know this thing through the interface, and it's not going to know even that it's the note repository. It's just going to know, and what I mean the presenter, that it's talking to some class that implements this contract. So now we've created this note repository which implements note data source, And of course, it's overridden the method of note data source. So we pass this note in, and now we have a data layer, sort of a high-level data module, which implements the interface, which has the responsibility of managing saving data. And that makes a lot more sense. This thing can have finer details about what it needs to do. So in this case, we have the note database, local storage, and the note network service, remote storage. And so we pass our note in, and then this thing is now responsible for this stuff. Now, if you're wondering, like, we wouldn't actually write it like this in a real app. You'd probably want to use RxJava so that you have callbacks, or you'd want to do this asynchronously, but this is just pseudocode. And then what we do is we actually have our note database and our note network service implement the contract as well. And so now we have a situation where our note database, everything implements the same contract. Again, there's no implementation, but this thing would be a realm database or room database. It would save the note, call back, and then basically the same thing with the note network service. It could be like an API. And so that's kind of that. So now our thing that needs to know more details about how the data source implementation will work knows that. We've taken that out of the presenter. So that's done a couple of things. For starters, it's simplified our presenter drastically. And when we simplify it, that does two things. It makes it easier to test, and it makes it easier to read. It's also just, it's good practice. And then we've created this extra class, which we've offloaded those responsibilities to. And then this thing can sort of worry about all the finer details of managing the data. So that is basically, in a nutshell, what's going on here. Now, to wrap things up, I want to talk about what we're actually doing here. So as opposed to designing our classes right from the get-go, tightly coupled, which means like we've got our presenter, which depends directly on two concrete classes, which makes it harder to test and harder to swap things out. Let's say we swap out for a different API, then we've got an issue, because not only will we have to change that API itself, but we'll also have to change the presenter, which is stupid. If you're making changes in the model, that shouldn't affect the presenter. If you find yourself changing things on one end of the app, and that change needs to be propagated across the other layers, the implementation needs to change, that's a big hint that you need to restructure things. You need to be depending upon interfaces, and you need to do the whole dependency inversion thing. Mainly like depend upon interfaces. Holy crap, it's like 30 friggin' degrees in my room right now. So anyways, hopefully I've done a relatively decent job of explaining how to, indirectly the dependency inversion principle. We've sort of inverted things so that our modules are depending or inheriting from interfaces. So we're basically having them communicate through like high-level communication lanes instead of like finer details. And then sort of as things get more complex, we create sort of finer and finer modules or parts of the app which have more and more detail about what's going on. Like for example, if I go back to our note repository here, the note repository doesn't even need to know, like we could even sort of write this as an interface, but this repository doesn't need to know what kind of database, it doesn't need to know what kind of remote service, but it knows that it's got those two things, and it rightly has the responsibility of delegating the data to those different services. So this was sort of the first example, this sort of repository pattern was the first time I ever sort of saw software architecture and thought, holy crap, because the thing about it was when I was building Profiler, I was running into all these different difficulties with testing and complexity. And when I started to see that I could kind of pull things out, yes, we get more classes, but that's not actually a bad thing. Like, in many cases, you'll be writing less lines of code because each part has fewer implementation details, which is less lines of code. Yeah, you have to make more classes, but just consider that. We sort of almost like stretch this architecture out into like more and more to like high level sort of abstractions and responsibilities into like concrete details and implementation and as necessary. And our dependencies sort of travel in that direction. We've got high level stuff depending on abstractions and interfaces, and then our lower and lower level stuff sort of implements those interfaces, and everything works well together. We can swap things out, we can mock things easily in tests, and it's easy to read. So that is my explanation on the dependency inversion principle. I really hope I did a good job on that, and yeah, let's take a quick commercial break and wipe the sweat